tab means testing, adjusting, and balancing air or water distribution to meet approved design requirements. It is one part of commissioning, not a substitute for design review, installation quality, controls functional testing, training, issue resolution, or life safety acceptance. Begin with the owner and project requirements, approved schedules, drawings, sequences, fan data, and stated tolerances. Convert design documents into a test plan before touching the system. Identify required total, branch, and terminal airflow, pressure, diversity and operating modes, plus fan and equipment limits. Do not invent one generic tolerance or treat nameplate maximum as design flow. Missing or conflicting criteria become documented issues for resolution, not field guesses. Complete pre-functional readiness first. Confirm clean and complete installation, guards and covers, filters and coils, ducts and supports, dampers and actuators, fire and smoke devices, electrical protection and grounding, belts and alignment, drains, sensors, approved test ports, and controls point-to-point checks. Unsafe or incomplete equipment is not run merely to collect data. Plan safe access to each measurement. Running systems can expose rotating parts, automatic dampers, electricity, pressure, hot or cold surfaces, chemicals, and elevated locations. Use permanent approved ports and guarded positions. Keep clothing, leads, cameras, and tools controlled. Removing a guard or panel for a better live reading is not acceptable. Select fit-for-purpose instruments. Document manufacturer, model, serial number, range, resolution, calibration or verification status, units, and applicable uncertainty for airflow hoods, manometers, probes, anemometers, tachometers, power meters, and environmental sensors. A phone application or unknown gauge cannot support a formal tab result. Zero instruments, inspect tubing, stabilize the system, and record units and sign conventions. Document air density or the temperature and pressure needed for correction. Never silently mix pascals, inches of water, CFM, liters per second, cubic meters per hour, feet per minute, and meters per second. Report only precision supported by the method. Choose a valid airflow method in station. A pitot traverse, velocity grid, flow hood, calibrated station, and fan method estimate have different requirements. Duct shape, access, velocity profile, swirl, and range determine suitability. One point close to a fan, elbow, damper, or transition is not total airflow. Verify rotation with the manufacturer-approved guarded procedure and de-energized physical indicators where possible. Wrong rotation may still move air. Electrical phase changes are qualified work. Do not expose a belt, coupling, or wheel, and never use a ribbon or hand near an operating inlet as a bump test demonstration. Capture the unadjusted baseline before making changes. Record fan command and speed, total airflow, pressures, motor current or power, filter and coil drops, branches and terminals, damper positions, control state, and environmental conditions. Compare the measured fan operating point with selected data and preserve deficiencies instead of hiding them with immediate speed or damper changes. Adjust in a controlled hierarchy. Follow the project method from systems and mains through branches to terminals where applicable. Make one class of change at a time, document it, allow settling, and remeasure affected upstream and downstream points. Preserve required ventilation and pressurization, and never wedge fire or smoke dampers, remove filters, or create leaks to meet numbers. After fan speed or controls changes, verify airflow, pressure, current or power, stable fan region, vibration, noise, temperature, coil and heat exchanger limits, ventilation, and combustion criteria where applicable. Functional testing separately exercises modes, resets, staging, interlocks, alarms, command and feedback, sensor failure, power restoration, and safe fail behavior under approved change control. Finish with repeat measurements and a traceable report. Preserve raw data, instrument and calibration details, locations, conditions, corrections, uncertainty, calculations, initial and final values, percent of design, pass status, deficiencies, and unresolved issues. Restore ports, panels, filters, guards, labels, and settings. Commissioned performance is repeatable evidence across defined modes, not one airflow screenshot.